So the start of this unit, we're going to start off with talking about a bit more on kinetics and then eventually get more into thermodynamics. So, right, kinetics is the study of motion, thermodynamics is the study of heat and energy. This lecture is going to be on kinetic molecular theory and the states of matter. Sometimes you'll also hear kinetic molecular theory, also called kinetic theory of matter, all pretty much the same thing. All right, so kinetic molecular theory is saying that particles of matter are always in motion. And you can kind of derive this, right? Kinetics, motion, molecular. All matter is molecular, right? And so kinetic, right? Motion, molecular is matter. So particles of matter are always in motion. And the amount and type of motion determines the substance's state of matter. We can measure the average kinetic energy of particles through temperature, and our lecture next class is going to be all about the difference between temperature and heat. Okay. So the states of matter, these are the things that we see matter in, right, or know that they're in. So we have solids, like a block of ice, liquid, like a cup of water, and gases, like water vapor. So we can classify states of matter based off of particle arrangement, energy of particles, and the distance between particles. So solids, these are tightly packed, they vibrate in a fixed position, they have a definite shape and volume, and they have many free surfaces. So that means, right, so like say you have a cube. If you have a cube, then you have 6 free surfaces, right? So cube, right? So if we have the top of it, we have one side, we have the other. So right, you can see 3. We know that there are another there, and then on the bottom, right? So there's many free surfaces available. You break it up more, you have it in different shapes, and you're going to have even more free surfaces available. Some properties of solids, right? With their definite shape and volume, their particles are locked into place. They're also not easily compressed because there's already little free space between particles, and they do not flow easily since the particles can't move or slide past each other. And all these should kind of make sense to you, right? When you have something that is solid, like let's say a dice, you can't really change the shape of that die. You can't just slide them off of each other. Some solids you can, so like graphite on your pencil you could slide off, but that's due to the shape. The actual molecular shape of graphite are sheets, and so you're sliding one sheet off of another, but the sheet is still intact. Then we go on to liquids. So these are tightly packed, but they are far enough apart to slide over one another, and you can kind of visualize that with how liquid moves easily, right? It has an indefinite shape and definite volume, right? So if you have a cup of water, you can give it different shapes, but it's always going to be a cup of water. And then there's one surface, so that top of it, right, is the only surface available to it, while there's a lot of other stuff going on inside. Some properties, right? They have this indefinite shape because the particles can slide past one another. They aren't easily compressible, and this is because of their definite volume is there because there's still only a little free space between the particles. They don't have a lot of free space, so you can't compress them too easily. And then they flow easily since the particles can move and slide past one another, right? And I'm pretty sure most of you can visualize pouring a glass of water and seeing the particles move easily. All right. And then we have gases. These particles are very far apart. In fact, right, there's nothing shown in this box compared to the other slides where they're more together because, right, it'd be like one gas particle and then it's gone. They move very freely. They have indefinite shape and indefinite volume, and they have no surfaces. And here's a couple of examples of gases down here. And we can change the state of any gas or of any compound, and we do this by applying heat or pressure, and we can force it into a state we want. We'll get more into that later on this unit. I think day 5 or 6 is when we start talking about ways that we can change the state of matter. So that's just the brief intro for this unit. Submit your notes on this video to Canvas.